All right, I just thought let me just go live before people be going to school. I can just imagine. I always imagine the mornings, the early mornings, people sitting there in the couch watching cartoons or whatever the case may be, or still are waiting for maybe transportation to leave. You are having your Kellogg's cornflakes, you're having your cereal, you are having your stew, you are having anything that you are having right now. All kind of people are scrambling for the door, preparing to actually get out and leave and go to work, right? So this is just for my grade 8s and 9s, specifically actually let's say the grade 9s, and probably will be relevant for the grade not only just the grade 9s, right, but also the grade 10s. Okay, grade 9s and grade 10s. So right now the grade 9s are busy with algebraic expressions, also like, because that's term 2 topics: algebraic expressions, equations, simplification of algebraic fractions. That's what grade 9s are busy with now at the moment. And then obviously with the the grade 9s also may possibly also be busy with functions and relationships, because that's the term 2 topics as they stand. So I'm just going to look at a bit of factorization, but before that, I'm sure you remember these questions, okay? Now, I just want to say to the grade 9s, you guys need to be able to differentiate between questions that have to do with simplification, all right, where you have a question like this, and factorization. Please read the question. What are you being asked? All right. So for instance, if you're asked to simplify this, all right, what I usually say to grade 9 learners is that if you're looking at this, guys, what you need to take into consideration always is this guy. You see this guy? You see this man? Okay, call it whatever you want to call him. This man is very important for grade 9s. Board mass or bad mass if you want. Remember, what does this stand for? Whenever we have different operations in an expression, different operations, we must apply board mass in this order, bad mass. So we obviously always start by looking at the brackets, and then we check what is inside the brackets and can we simplify whatever is inside the brackets, because that's where we start. Then after we looked at the brackets, we then look at exponents. We must make sure we have the exponents. We check what's happening with the exponents and see if there's anything that ought to be done where exponents are concerned. From brackets to exponents. Then D stands for division. All right, my beloved grade 9s, division in that order. M stands for multiplication. A stands for addition. And then S stands for subtraction. So hopefully my grade 9 learners, you understand that whenever you are given an expression and there are many operations, bad mass needs to be considered when you are actually attempting a problem of that nature. So like I said, B stands for brackets, E stands for exponents, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. Bad mass. Very, very critical. So if we come here, you look at this, you have 9 minus 7. Then you have a bracket, 2 brackets in actual fact. Each bracket, one bracket has x minus 1 in it, and the other bracket has x plus 1 in it. So if you are looking at this, what comes to mind is what? Bad mass. So what do we start with? Brackets. Now if we look at the brackets, guys, x minus 1 and x plus 2, the x minus 1 and the x plus 2, inside of them there are no like terms, or there's nothing that we can simplify inside the bracket. So that means for now, inside, because when we look at the bracket, we must first look inside each bracket. Then 2, we need to look at the brackets now. Seeing that there's nothing inside that we can simplify it, then we need to look at the brackets themselves. So the brackets, we have -7, the bracket, and then another bracket. Now brackets mean something in mathematics. Brackets mean multiply, right? Brackets mean multiply. So the moment inside each bracket there's nothing to simplify, then we move on to the next ring of understanding where brackets are concerned. Those things that stand next to the bracket, okay, this numerical coefficient of -7, the bracket that's next to this bracket, that means multiplication. So I need to then go down my order: brackets, exponents nothing, D no division, but remember brackets mean multiplication. So that means that's the next thing I need to consider for my expression: the -7, its relationship with the bracket and the relationship with that bracket. So therefore multiplication has to then what? Take place, because brackets mean multiply. Very, very important. So here I have to put priority over this -7 with the bracket, with this bracket. Okay, so I am going to write down the 9 because it's not going anywhere. It has to wait its turn. Then I write down the -7. It is not going anywhere. It has to await its turn. Then I'm going to put priority on the x minus 1, this bracket and this bracket together. So I'm going to play with the multiplication and I'm going to apply the distributive law. Distributive law. And as I do that, I'm going to apply what I usually refer to as SNL. I'm going to apply the distributive law, and when I do so, I'm going to make sure I multiply the signs in each situation, I multiply the numbers in each situation, and I multiply the letters or the variables in each situation. So let's look at this. Look at this. So the x minus 1 and x plus 1, the x times the x. This is what I mean by distributive law. You're going to distribute the x to the x and distribute the x to the positive 1. When you do that, remember the multiplication of the sign, the multiplication of the number, the multiplication of the letter. So that's why I say multiplication in this situation means the distributive law, and we multiply the sign, the number, and the letter as we go along. So here we go. X times x. All right. So that means I'm going to have a bracket, because my result, the result of what I get with the multiplication of this bracket and this bracket, needs to still be contained within a bracket. Why? Because there's a -7 which is outside the two brackets here. So we're going to say x times x. Now x times x is x to the power 2. Why? Because remember, x times x, when you are multiplying same bases from law of exponents in term 1, you keep the base and then you add the exponents. So there's an exponent 1 that is invisible for the x, and there's an exponent 1 that's invisible for this x. So when you are multiplying x and this x, you keep the base, you add the exponents. So we have x squared. Then we take x and we distribute him to positive 1. So the first term needs to be distributed to the first term in the bracket, and then the first term needs to be distributed to the second term in that bracket. So now we are going to say x times 1. Remember, when we are multiplying, we apply the sign. In other words, the x and the 1. This one is positive. Positive times a positive, that will give us a positive. Sign, done. Then we go to the number. The coefficient of x here is 1, and 1 times 1 gives us 1. Then we say x, the x variable, that will leave us with 1x. So we can just write positive x. Then we take the -1 now, the second term in this bracket, and we distribute it to the x variable there. -1 times x gives you -x. And then -1 times positive 1. Remember, a negative times a negative is a negative times a positive is a negative. And then 1 times 1 is 1. We close that bracket. So that is us distributing a bracket and another bracket. We multiply the first terms, we multiply the outer terms, we multiply the inner terms, and we multiply the last terms. And we get x squared plus x minus 1, and the bracket we keep. We are not done, so 9 minus 7. Now inside that bracket there are like terms. So x squared has no like terms, so we keep x squared. Positive x minus x, that gives us a 0. And then the negative 1 just has to be there as our second term. Okay, so why is x gone? It's because x minus another x gives you 0. So that's why we are left within the bracket, we are left with x squared minus 1. Now we move on. Remember, we said brackets mean multiply. So we did multiply these two brackets as our first priority. Now we are left with 9 minus 7 with a bracket of x squared minus 1. So what do we do now? We have to take the 7 and look at the relationship of the 7 with this bracket. Brackets mean multiply. So that means now we need to distribute the negative 7 into x squared, and again the negative 7 into the negative 1. And when we do that, we need to consider multiplication of the sign, multiplication of the number, multiplication of the letter. So let's go. Negative times a positive gives us a what? Remember, we first write down the 9. The 9 is there, still waiting its turn, because its turn has not come yet. So we take the negative 7, we distribute it to the x squared. Negative times a positive gives us a negative. 7 times, remember here there's a invisible 1. So that 7 times 1 gives us 7. And then the x squared, that gets attached as the letter with the exponent next to the negative 7. Done. Then we take the negative 7, we distribute it to the negative 1 by multiplication. So what's negative times a negative? That gives us a positive. What is 7 times 1? That gives us a 7. Now look, we have 9 minus 7x squared plus 7. So in this situation now, remember we went through brackets, and from the brackets we multiplied the brackets that we had so that we could apply the distributive law. Now what we see is we have 3 separate terms, that in those terms we can see that we have what? Like terms. Okay, so for BEDMAS, after multiplication we look, do we have addition and subtraction of what? Of like terms. Because remember, for expressions we can only add and subtract what? Like terms. So let's look here. 9 and 7, they are like terms. Negative 7x squared is a term that is unlike these two. So the negative 7x squared I'm going to write down. Okay, all right. But then this 9, the 9 is what? It is positive. The 7, it is what? It is also positive. So now I can add these like terms, 9 and 7, because they are like terms. So the final answer will be negative 7x squared. What is 9 plus 7? 9 plus 7 is 16. And guys, these two terms are unlike terms. Therefore, the answer is negative 7x squared plus 16. You cannot add and subtract these terms because they are unlike each other. Why do we say they are unlike each other? It's because if you look at 16, it is a constant term. It is a term that has no variable or letter, whereas negative 7 has an x squared, which is therefore different. These are like two different kids from two different schools. The uniform here has a jersey, which is x squared. The uniform here has no jersey because there's no similar what? X squared for this term. So therefore these are unlike terms. We cannot add or subtract unlike terms, so we leave our answer as negative 7x squared plus 16. So guys, that's how we deal with what? With simplification of expressions where there is different signs that are in the mix. I'm gonna do 3 more before I have to go to work, because I have to go to work shortly. Let's look at this one. 2x plus 5 into 3x plus 7. So once again, when we look at this, we need to ask ourselves the first question that we always ask ourselves when we are looking at expressions and we're asked to simplify. We ask, how many terms do we have in the expression? Now obviously this is one term. All right, and why do we say there's one term? It's because brackets combine things, guys. Brackets combine things. So even though there's 2 brackets, this obviously gives us a multiplication relationship because brackets mean multiply. But we say this is one term. So it being one term, what are we going to consider? BEDMAS. Brackets, exponents, division, multiplication, addition, and subtraction. If we look inside the brackets, there are no like terms. So therefore the brackets, we are done. Go to exponents. Are there exponents? No. Okay. Except obviously for each term here, the exponent 1 is there, but it has no effect. 2, division, no division. 3, multiplication, or definitely this bracket and this bracket together mean multiply. So it means I need to multiply 2x plus 5 with 3x plus 7. So when we multiply, we always apply the distributive law. And when we do so, we consider S and L. Guys, M means multiplication. DL means we apply the distributive law. In other words, 2x needs to be distributed to 3x by multiplication, and then 2x needs to be distributed to 7 by multiplication. We multiply the first term, F, we multiply the outer terms, O, we multiply then the inner terms, I, we multiply the last terms, L. Then when we do that, we must make sure that we are multiplying S, the signs, N, the numbers, L, the letters. We consider those 3 things as we multiply. So let's go. What's 2x times 3x? Okay, so a positive times a positive will give us a positive answer. 2 times 3 for the numbers. What's 2 times 3? That gives us 6. X times x. When we are multiplying same bases, variable x, we keep the base x and we add the exponents. And yes, it is 6x squared. Very beautifully said in the comment section. Then we take the same term and we distribute it to the outer term for this bracket. What's 2x times 7? When we multiply, we consider the sign. Positive times a positive gives us a positive. Then we move on to the number 2 times 7. What's 2 times 7? It is 14. Then there's an x variable that is supposed to be multiplied. There's no variable of x there, so we say x. Oh wow, thank you so much for the "you're awesome" gift. I really appreciate it. Lots of love and appreciation to you. Then we multiply now. After distributing the 2x completely to this expression, we take the 5 that is positive and now we distributed it to the first and the second term. So let's go. Positive 5 times 3x. A positive times a positive is a positive. Sign has been taken care of. We go on to the number. What's 5 times 3? It is 15. And then the variable x gets attached to the coefficient that is 15. Then lastly, positive 5 times positive 7. What is a positive times a positive? That gives us a straight positive answer. And then what's 5 times 7? That is 35. So our multiplication part has now been taken care of. Remember, we were going down: B for brackets, E exponents, D division. So we found that exponents and division are not there. We move on to multiplication. Our brackets mean multiplication. All right. Then what do? We apply the distributive law and you make sure that there's S and L. Then last but not least, when we have done with the distribution, then we look after multiplication, what follows for BEDMAS? Addition. Addition and then subtraction. So for addition and subtraction, we only add and subtract like terms. Very good, in the comment section. So therefore, like terms that we have in the expression are in the two terms that are in the middle. What's 14x plus 15x? Remember, when we add like terms, we keep the variable. So if these are two kids with their respective uniform, they wearing the same uniform. All right, there's 14 of those kids this side, there's 15 of those kids this side. So 14 plus 15 of those kids gives us 29 kids with the what? With the same uniform. So the variable doesn't change when we are adding like terms. What changes is the coefficient. 14 plus 15 is 29. We retain the x, and then the 35, which is our constant term. So all in all, our final answer is 6x squared plus 29x plus 35. Why is this the final answer? Remember, 6x squared is different from 29x, is different from 35 with no x or x squared. So these are unlike terms. We cannot add or subtract unlike terms. So we leave our answer at this stage. Okay, now I'm going to do number B, or letter B. 5x minus 3 into 7x plus 2. So once again, we ask our first question: how many terms do we have in the expression? Now, 5x minus 3 into 7x plus 2, you can see this is one term. Why is it one term? It's because brackets make it such that it is one term. So we then do what? We are going to consider the brackets. Brackets mean multiply. Inside the brackets, there's no like term, so there's nothing that we can do with the brackets. We move on to the same thing. Next step, exponents. Exponents, no exponents. We move on to D. D stands for division. Division, no division. M. M, oh, brackets mean multiply. So our M means multiply. So with multiplication for two brackets like this, we must apply the distributive law. We are going to take this 5x and distribute it to the 7x. Okay, so we apply the fold method. Definitely the fold method is simply us distributing 5x into 7x, our first terms, F, 5x multiplied by 2, which is our O, outer terms, negative 3x being distributed to 7x, our inner terms, I, and then negative 3 times the positive 2, our last terms in the bracket. So let's go ahead and do that. And remember, when we apply FOIL, we must consider the sign S, the number N, the letter L. We multiply the sign, the number, the letter for each situation that we are dealing with. So let's see what we have here. 5x times 7x. So we start with the sign. Positive times a positive is a positive answer. We move on to the number. 5 times 7. What's 5 times 7, guys? It is 35. We move on to the letter. X times x. That gives you, we keep the base variable. We add the exponents when we are multiplying same bases. So that will give us x to the power 2. Remember, there's an invisible 1 for each exponent that you do not see there. It's like God, invisible but present. That's unseen 1. It is there, always there. So that's why we get x to the power 2. When we are multiplying same bases, we keep the base, we add the exponent. Now we move on to 5x times the 2. What's 5x times the 2? Once again, positive times a positive gives us a positive. 5 times 2 gives you 10. the x variable next to the 10. Then we multiply the inner terms now. What's negative times a positive? That gives you a negative, guys. Negative times a positive gives you a negative. This is us multiplying the inner terms. What's 3 times 7? Now we move on to the number. 3 times 7 is 21. The x variable next door. All right. Then lastly, negative 3 times positive 2. What's negative times a positive? That's negative. What's 3 times 2? It is 6. So what do we now have? 1, 2, 3, 4 terms, guys. And our multiplication is perfecto mundo, if you ask me. Now, we move down the ring of BEDMAS. We did the brackets. There was nothing inside the brackets. E, we looked at the exponents, no exponents. D, division, no division. M, the brackets mean multiply. So what did we do? We did FOIL. We applied the distributive law, applying S and L as we multiply each term. Move on to the next rank. After M is addition. Oh, addition and subtraction. Now look at the 4 terms. Which terms can be added and subtracted? It is 10x and negative 21x. Why? Because these are like terms. Why do we say they are like terms? Like terms are identified by having the same either variable and exponent. X squared is not the same like term as 10x. Why? Because even though the x's are the same, the exponents, this one is 2, this one is 1. That's what makes these two distinct, separate, and unlike each other. But 10x and negative 21x, the variable and its exponent are the same. So therefore we say these are like terms. Same jersey, same uniform, kids that are in the same school. So we say 10 of them minus 21 of them. How many of them do we have left? You get the situation. We have negative 11. But the jersey and the uniform is worn by that learners of that school. 35x squared, on the other hand, will stay as it is. So it's 35x squared minus 11x. And the negative 6 is a constant term. It has no friend. These here, can we add and subtract any of these? No. Why? Because there's unlike terms. Let's go and do this last one, guys, and then I can have to leave and head to school. All right. 2 into 3x minus 1, the whole thing squared. First question we ask, how many terms do we have in this expression? So the answer is we have only one term. Why do we say one term? Because brackets do this thing of combining things together. So this is one term. Next question. What do we have in this term? We have 2. We have a bracket. We have an exponent. So when we go down, our B, E, D, M, A, S, brackets, exponents, division, multiplication, addition, and subtraction. We look, brackets. We have brackets there. Exponents. Hey, we have an exponent. So therefore, what does that mean? With our bracket, because the exponent is 2, it means we need to open 2 brackets of 3x minus 1. Hey, brackets, exponents. With our exponent, it means we have to open 2 brackets of 3x minus 1. There's 2 of these, so there they are, and they are multiplied with each other. Then, after B and E, is there any division? No. Multiplication, yes. The relationship that exists between 2, the 3x minus 1, and the 3x minus 1 is multiply. So therefore it means we are going to keep the 2 for now, and we are going to play the game of FOIL with these 2 brackets. And when we play the game of FOIL, we consider distributing and the sign, the number, the letter. So let's go. What do we have? 3x times 3x. I'm sure now you guys are so fluent. Okay. I know, hey. That's why I am explaining it. That please, guys, When you are looking at an expression and they are saying simplify, please ask yourself the first question: how many terms do you have in the expression? Then after doing so and identifying how many terms, you move on and you check BEDMAS. You check brackets. What's happening inside the brackets? E, exponents. You see, exponents, what are they saying to me? D, M, A, S. If you go down that, you'll be fine. 3x times 3x is 9x squared. What's 3x times negative 1? That gives us negative 3x. Then what's negative 1 times 3x? That gives us another negative 3x. And then last but not least, what's negative 1 times negative 1? That gives us positive 1. Hey, we are going somewhere. 2 has not disappeared. It stays. It's there. Okay, we have not forgotten about good old 2. It's still there. Then inside the bracket, let us sort out what is happening inside them. What's negative 3x? Negative 3x, those are like terms, so we get negative 6x. Plus 1 is still there, not going anywhere. Hey, me, I'm going to be late. All right, guys, this is going to be my last problem. Sorry, ne? Then we have 9x squared minus 6x plus 1. So inside the bracket, we have how many terms? 3 terms. Outside the bracket, we have this 2. Hey, it was patiently waiting, wanting to have the opportunity of being. Remember, brackets mean multiply. So what we are going to do, we are going to distribute. Okay, so here we go, guys. We are going to, brackets mean multiply. So we are going to multiply 2 times x squared, 2 times negative 6x, 2 times positive 1. We distribute the 2 to the 9x squared. We distribute the 2 to the negative 6x. We distribute the 2 to the positive 1. Brackets mean multiply. 2 times 9x squared, 2 times negative 6x, 2 times positive 1. The relationship between the 2 and the bracket is one of multiply. So we apply the distributive law, and we don't forget to consider, as we multiply, the multiplication of the sign, the multiplication of the number, the multiplication of the letter. Guys, these 3 letters, S and L, sign, number, letter, surely you will look at them in a different way from now onwards. If ever you see these S and L in a movie as you are watching it, please, guys, it means you need to switch off the TV and you need to go where? You need to go to your maths book, open it, and do algebraic expressions. It means that your time is up watching the television screen, because you won't go anywhere watching movies that have SNL. But if you apply SNL, your algebraic expressions, you will go very far in mathematics. You see what I mean? Guys, you got to love this, man. Sis. All right? So 2 times 9x squared, 18x squared. 2 times negative 6, negative 12x. 2 times 1, positive 2. Aye, hands clap, hands clap. So guys, that was it. Thank you so much. I'm going to have to leave. I'm going to end the live now. We'll see each other again tomorrow morning, 30 minutes. For another exciting episode, guys, but not at 7, maybe at 6. Actually 5:30 tomorrow we'll have another session for the grade 9s, so that we continue this revision session. This is our build up. I will be uploading this session on my YouTube channel, so you can check out my YouTube channel. My YouTube channel is called Maths is a Game. You can go to my bio. The link is in the bio for the YouTube channel. Click on the link, go there, subscribe. I'll be uploading the video so that you guys can, those who may have missed out, can watch it. Cheers, cheers, cheers. Love you, love you. Goodbye. Have a good day at school.